Hello guys, welcome back to our YouTube channel. Welcome to Add Maths Plus Maths. We are now going to discuss laws of exponents as part of our algebra lessons in mathematics. This will be the part 1. We will be having part 2 following this video. First thing that you need to understand is what do we mean by index or power or exponent. Index, power or exponent is the number of times you multiply a number to itself. Just for example, the number that you are seeing now on your screen that says 7 times 7 times 7 times 7 times 7, or as I will say it, you multiply 7 5 times to itself. So when you say you multiply 7 5 times to itself, you can write this as well as 7 to the power of 5. 7 to the power of 5. Meaning 7 is your base and 5 is the number of times that you multiply the number 7 to itself, which is what we call the index, the power, or the exponent. Okay? Now, let's move on to the first rule or first law of exponent. In multiplying numbers with the same bases but with different indices or exponent, what you will do is, let's try to investigate first and apply what we have learned a while ago, that 3 to the power of 2 or 3 raised to the power of 2 is equivalent to 3 times 3, and 3 raised to the power of 5 is 3 times 3 times 3 times 3 times 3, or you multiply 3 5 times to itself. Okay, and then you just basically multiply. But if you will notice here, if I am going to count, I have now 3, 1, 2, 3, 4, 5, 6, 7. This can also be written as 3 to the power of 7, because there are 7 3's that you are multiplying to itself. Okay, so 3 to the power of 7. Meaning, if I am going to multiply a number with the same base but with a different index or exponent, okay, I am just going to add 2 plus 5 will become 7. Coming into that will give you the first rule of exponent, which is a to the power of m times a to the power of n is equal to a to the power of m plus n. So you just need to add the exponent or the indices. That is the first rule. How about in dividing? If I am dividing, okay, of course, it can be written as 6 times you multiply 3 to itself divided by 2 times you multiply 3 by itself. Okay, remember, if I have something like this, I can remove, I can remove those 3 and another 3, because so that I can remove everything. I will be left with 4 3's, 1, 2, 3, 4. Okay, which means I can have a result of 3 to the power of 4. But is there another way on how to find out 3 to the power of 4? I will just basically subtract the indices. 6 minus 2. Okay, 6 minus 2 is equivalent to 4. Thus, we'll give you the second rule, which is a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Next, raising to a power. how about if I raise a certain number with an index to another index? For example, I have here 4 to the power of 2 to the power of 3. I can write 4 times 4, then I will multiply it again with 4 times 4, then I will multiply it again with 4 times 4. You will notice that if I will count how many 4s am I multiplying to itself, I will have 6, which gives you 4 to the power of 6. Question, is there another way on how we can do this without expanding it to brackets like this? I can just multiply the indices. 2 times 3 is equivalent to 6. So that will lead us to the third rule, which means a to the power of m to the power of n is equivalent to a to the power of n times n. M times n. Okay? So these are the first three rules. Let's try to apply. Simplify first. Y to the power 4 times y to the power 5. Y to the power 4 times y to the power 5 is multiplying rule. So we will be using rule number 1. Basically, we will just add the indices 4 and 5. 4 plus 5 will lead you to y to the power of 9. Next, letter B. X to the power of 7 divided by x to the power of 4. It will lead you to using rule number 2, which means I am going to subtract the indices 7 and 4. 7 minus 4 is equivalent to x to the power of 3. Okay? Letter C. P to the power of 3 to the power of 4. P to the power of 3 to the power of 4, meaning I can multiply the indices. 3 times 4 will lead you to 12. P to the power of 12. Next, simplify the following. Letter A. 2 to the power 2p to the power of 2 q to the power of 5 times 5p raised to the power of 4 times q to the power of 3. How are we going to do this? You can multiply the numerical coefficients 2 and 5. Okay, multiply first 2 and 5, then multiply p to the power of 2 times p to the power of 4. Then you multiply q to the power of 5 times q to the power of 3. Okay? 2 times 5 is equivalent to 10. P to the power of 2 times p to the power of 4 will lead you to the conclusion that it can be p to the power of 2 plus 4. And q to the power of 5 times q to the power of 3 will lead you to the conclusion that q will have an exponent of 5 plus 3, which will give you an answer that 10 times p to the power of 6 times q to the power of 8. Let's move on to letter B. I have here 6a to the power of 5, b to the power of 7 divided by 2a to the power of 2, b to the power of 3. What will I do? I can divide 6 and 2. 6 divided by 2, then I will divide a to the power of 5 divided by a to the power of 2. Then I will divide b to the power of 7 divided by b to the power of 3. Now, question, can I divide a to the power of 5 and b to the power of 3? No, because they have different bases. Okay? Of course, you can divide them if they already have their values, but this time you can not divide yet. Okay? Now, 6 divided by 2 is equivalent to 3. A to the power of 5 divided by a to the power of 2 is equivalent to a to the power of 3. And b to the power of 7 divided by b to the power of 3 is b to the power of 4, because 5 minus 2 is a to the power of 3 now, and 7 minus 3 is b to the power of 4. So the answer here is 3a cubed b raised to the power of 4. Next, how about negative powers? If I will be given 3 to the power of 2 divided by 3 to the power of 4, you will notice that if I will subtract and use the law number 2, I will subtract 2 minus 4. Remember, 4 minus 2 is different from 2 minus 4. 2 minus 4 will lead you to a negative index. Okay? You will notice if I will cancel this out, I will be left with 1 over, okay, 1 over 3 to the power of 2, because those 3 that was left behind was in or on the denominators or denominator. Okay? Therefore, I will come up with 3 to the power of 2 minus 4. This applies your law number 2. 3 to the power of 2 minus 4 is equivalent to 3 to the power of negative 2. Okay? Which will give you an idea that 1 over 3 to the power of 2 is also equivalent to 3 to the power of negative 2. And 3 to the power of negative 2 is equivalent to 1 over 3 of power of 2. Thus, we'll give you the fourth rule of indices or law of indices, that meaning a to the power of negative n is equivalent to 1 over a to the power of m. Okay? What does this mean? You will just think that if I have a negative index, I'll bring it down, it will become a positive index. Next, let's try to apply. Oh, there's another law, which is 0 powers. 0 powers, if you will notice, 3 to the power of 4 divided by 3 to the power of 4 is 3 to the power of 0. Why 3 to the power of 0? Because 4 minus 4 is equal to 0. And if you will expand it, it will be like this. And I will cancel that out. I will be left with nothing but 1. Okay? Because 3 divided by 3 is basically 1. Okay? You can write this also as 3 to the power of 4 minus 4, which is 3 to the power of 0. Thus, will lead you to an answer that, or conclusion that 3 to the power of 0 is equivalent to 1. Okay? So any number that is raised to 0 is always equal to 1. Even if you will raise 1 million to 0, it will still be equivalent to 1. So that's our fifth rule of indices. Now, let's move on to some examples. Work out the values of a 2 to the power of negative 3. If I will work out the value of that, since it's a negative index, I will bring that down to make the index positive. So it will become 1 over 2 raised to the power of positive 3. And 1 over 2 to the power of 3 will be 8. 1 over 8. Next, B. 7 to the power of 0 is equivalent to 1 because it's raised to 0. C. Negative 2 raised to the power of negative 3. Again, the index is negative. So what will happen here is that I am going to bring down the whole number, negative 2 to the power of negative 3, and make that index negative 3 positive. Please do not change the sign of the base number. I repeat, please do not change the sign of the base number. What is the base number? It is negative 2. I am going to change only the sign of the index. okay, which will lead you to 1 over negative 2 to the power of 3. And negative 2 raised to power of 3 is 1 over negative 2 times negative 2 times negative 2. And negative 2 multiplied 3 times to itself is equivalent to negative 8. Will lead you to an answer of negative 1 over 8. Next, last, how about 3 over 4 to the power of negative 2? 3 over 4 to the power of negative 2, what you will do here is to find out the reciprocal of 3 over 4. Okay? And make the index positive. It's the same thing. Okay? So it will become 4 over 3 to the power of 4. So the numerator becomes the denominator, and the denominator becomes the numerator. So I have that. Next thing that you will need to do is to distribute that index. 4 to the power of 2 is 16, and 3 to the power of 2 is equal to 9. So it will be 16 over 9. Next, simplify y to the power of 4 times y to the power of negative 7. Okay, since this is multiplication, I will apply rule number 1 and add the indices. But when I add, the result will be y to the power of negative 3. Okay, and y to the power of negative 3 should be written as 1 over y to the power of 3, because there is a rule in mathematics that you cannot leave a negative index. Letter B. 3x to the power of negative 5 times 2x to the power of 4. So you will notice that 3 times 2 can be multiplied. It will become 6. Negative 5 and positive 4 can be added since they are the index of the base x. Okay, so this will come out. 3 times 2 is 6. Then you will multiply x to the power of negative 5 times x to the power of 4, meaning x to the power of negative 5 plus 4. Okay, then you will come up with 6x to the power of negative 1. By the way, again, I repeat, this should be written as a positive index, so it will be written as 6x to the power of negative, or 6 to the power of, okay, I'll just write this, 6 over x. This one should be written as 1 over y cube. Okay, next, let's move on to letter C. Letter C, y to the power of 4 divided by y to the power of negative 7. Y to the power of 4 divided by y to the power of negative 7, meaning you will subtract. Rule number 2. Y to the power of 4 divided by y to the power of negative 7 will lead you to y to the power of 4 minus negative 7. And it will become y to the power of 4 plus 7. Okay? Y to the power of 4 plus 7, meaning it will become y to the power of 11. Next, letter D. P to the power of negative 3 to the power of 4. It will lead you to an answer that I will multiply negative 3 and 4. Multiply the powers will give you an answer of p to the power of negative 12. But again, I need to write this as 1 over p to the power of 12. Okay, 1 over p to the power of 12. Okay, because I cannot leave a negative index as my final answer. Next, let's move on to the summary. Okay, so this ends the lesson for today. I will just summarize it. So rule number one, if I am multiplying two numbers with the same basis, okay, but the index are given, I am just going to add those indices or exponents. If I am dividing two numbers with the same basis, okay, index are given, I will just subtract the indices or exponents. If I am given a number with an index raised to another index, I will just basically multiply those indices or exponents. If I am given, rule number 4, if I am given a negative index or negative exponent, I will just bring it down and make the index or exponent positive. And rule number 5, if a number is raised to 0, then it is always equivalent to 1. Thank you for watching. Please don't forget to like and share the video if you have learned something today. And also, if you haven't subscribed yet, subscribe to our channel and push that notification bell down below so that you will be updated with our new uploads of mathematics lesson videos.